Docker Compose is amazing. I mean, it's unbelievable. With just a few lines of configuration, you can have multiple services up and running and talking to one another automatically. It's as if I made a party and invited my friends from different friend groups and they all just got along and had a great time together. Now, of course, I don't go to parties and I don't have friends, but I would imagine it would work something like that. Now, this is part 2 on a free YouTube course on Docker called Docker for Noobs. If you haven't checked out the first episode yet, then subscribe, watch that episode, and then come back here. I'll wait for you, I promise. But in this video, we are going to go over Docker Compose, and we're going to break down a Docker Compose file together. I will show you how services talk to one another automatically in a Docker Compose system, and we'll even talk about how to store data outside of Docker containers for our database. And we're going to do this all in a real live application that we're going to build together in this very episode. So this is it. This is Docker for Noobs episode 2. Let's get into it. Now, Docker is an amazing tool for developers. It gives you the freedom and flexibility to develop things in a consistent environment. You don't have to manage your dependencies because Docker will install them all for you, and it's just a great way to work on applications. Docker can even deploy stuff in production, and you can actually ship things with it. But if you have a web application, you probably have multiple services that need to talk to one another. I could think of just a basic example. If you have a Rails app, then you have a web service and a database service. Now, you can't really use Docker independently for these two things. How do you get them to talk to one another? These are individual containers. How do they speak to one another? Well, the answer is Docker Compose. Docker Compose is a tool for creating multi-container applications where services can talk to one another easily and efficiently. Here, let's get into an example. We are actually going to show how to use Docker Compose with a real-world application. It's going to be a simple Ruby on Rails application, but the main tenets can be applicable to any other app that you might be developing for yourself. So let's dive right in. We're actually going to create a new Ruby on Rails application to use with Docker. So we can just write a Rails new command with the Docker Compose. That's the name of our Rails application. And we're going to make sure our database is PostgreSQL because that's what we're testing with. We're testing with our web application service and the database service. And we want to make sure these two things can talk to each other in our Docker Compose setup. So let's create this new Rails project. Okay, so now this project's set up, let's get into creating a Docker Compose file. So again, the goal of this video is to create a Docker Compose solution that can have two services in our web app talk to one another. These services are the web server, which in Rails is Puma, and the database server, which we are using as Postgres. So let's put down a quick diagram of what we're trying to do here. Okay, we are going to have a web service, which in our case is going to be Puma, which is just the name of the Rails server that Ruby on Rails likes to use. And we're going to have a database service, DB. And that database for us is going to be Postgres. So what we want to do is we want to have a system where Docker Compose can launch both of these services and have them basically talk to one another without there being any issues. We also want some redundancy. We want to make sure these services are healthy, and we also want to be able to work on them locally. Okay, so this isn't just for deploying to production. This is for local work, because what this does is this gives your whole entire team just a much easier setup when it comes to actually installing dependencies and getting to work on whatever project you're working on. Docker will handle all the dependencies for you. So let's get into this Rails app. So the first thing we're going to want to do is actually create a Docker Compose file, which is a YAML file, which will contain all the configuration that we want in the base directory of our application. So we have CD'd into the base directory of our example Rails application. What we want to do is create a new Docker Compose file. Now, in later Docker versions, you only need compose.yaml. I think previously it was docker/compose.yaml was the naming convention, but compose.yaml works now. So we create a compose.yaml file. Here's the thing, I could sit here and type out a YAML file line by line and try to explain it, but I think that would take too long and it would be really boring to say the least. So what I'm gonna do here is actually paste a whole entire YAML file with everything we need for our setup, and I'm gonna go and explain it line by line. I think that'll help with explaining how this stuff works and how all these pieces fit together. Let's paste this YAML file just like that. Now we can start to explain line by line what's happening here. And don't worry, by the end of this, you will understand exactly what's going on. I'm gonna break it down for you. So the very top level of this YAML file, we have an attribute called services. Now this denotes the block for services in the YAML file. Pretty self-explanatory. And we can see that one level in, we have two services here. One is DB, which is our database service, which we explained earlier in that little excellent diagram we just wrote. And the second service is web. These are the two services that we want in our Docker Compose environment that we want to talk to one another. Pretty straightforward, right? Good. We're going to explain a little bit more about these services and their names a little bit later. So next we are going to dive into the DB service and explain all of these attributes and what they mean. Now, the very first line here is the image we want to use for our database. Now, if you remember from our previous episode, an image is essentially a built Docker file that we then use to launch a container. So if you remember, this image is going to be the Postgres image with a tag of 16. Our images are specified as the name and a colon and then the tag. So this is going to be Postgres version 16. If we don't have it locally, then Docker is going to look up to Docker Hub, install all the correct things, and we will have Postgres version 16 running in this containerized environment. The next attribute is the environment attribute, and this specifies some environment variables that we want loaded when this container loads. So for Postgres, we're going to need a Postgres user and a Postgres password. But as you can see, we actually don't have values here. We have variables. So what are these things? Docker Compose by default will use a .env file to load variables. So if you want to store your variables in a place that isn't your Docker file, which probably isn't something you want to do, then you can store them in .env as long as it's in the same directory of this Docker Compose file. So we have a .env file right here. And if we open our .env, we see we have a few variables. We have database host, which is for our Rails section. We'll get to that in a minute. We have Postgres user and then Postgres password. So this is our env file, which stores all the variables for this system. I'm trusting you guys with this one. Don't copy these down because that is a secure password I use for everything. Now, of course, I'm kidding about the whole password thing. You see, I don't use my passwords over and over again. In fact, here at Typecraft, we don't reuse passwords at all because we have a strong password storage solution thanks to the sponsor of this video, NordPass. NordPass is an amazing password storage and sensitive information sharing platform that is amazing for businesses. So here at Typecraft, we use it all the time, and a really awesome part of the NordPass platform is the ability to set your custom password policies for everyone in your organization. So you can have complete control over how strong your passwords are, and they can follow as strict of a guideline as possible that you want for your whole entire organization. And they also have an excellent Chrome extension. So if I wanted to go to, let's say, I don't know, our Stripe business account, I could log into Stripe using NordPass using the Chrome extension. You can see right here, it is prompting me to log into NordPass so that I can unlock the password and username autofilling options. Now, I'm not going to actually show my login for our business Stripe account here in this video, but everything with NordPass, the platform itself, the Chrome extension, it works amazing. So use the coupon code Typecraft at nordpass.com/Typecraft to start a new business plan with 20% off. This coupon code applies only to new business plan accounts. Okay, let's get back to Docker Compose. Okay, so now let's get back to our Compose file and let's move on to the next piece. Okay, we move down this configuration file a little bit more and we see a new attribute here called volumes. What the heck are volumes? In Docker, a container is something that is ephemeral. So anything that's stored on that container will most likely go away if that container is stopped or deleted. So you don't want any of your precious data to live on the container. Now, the volumes section is the solution to having data live somewhere else so it is persisted. Let's explain how that works. In this section, we can define the volumes that we want to use for this container. So down here, we see our volume says PG data colon and then a path. PG data is the name of the volume that we want mounted into this container. And then the right-hand side of that colon is the path that this volume gets mounted to onto the container. So whenever the container saves some data, like in a database, it actually gets saved to the PG data volume. And you can define your volumes under the volumes section of the Docker Compose file. So we define volumes PG data. So we have PG data defined down here, and then we use it up here in the volume section of our database service. Next, we have what's actually a pretty interesting command, and that is health check. Now, in a multi-service setup for a web application, or I mean any application in general, you want to make sure that all of the services that are talking to one another are healthy or that they're actually running. So that's what this section of our Docker file is doing. We are defining how to run a health check for the database service. So under the health check attribute, we have a few more attributes that we need in order to check that this service is healthy. The first attribute is test. Now test defines what actual command gets run to check if this service is healthy. And we know it's healthy if it exits with a 0. Now 0 is a successful exit code in Linux or Unix systems, and anything else is non-successful. So as long as this test exits with a 0, then we know it's healthy. Let's explain that a little bit more. If I were to just echo out literally something, right, it would print that out onto the screen. Now I can check the previous process's exit status by echoing out $? That will give us the previous exit status for the previous program that was just run. And for us, since that echo was successfully, it gave us a 0. Okay, great. So if I echo something and then attach another command to it, like something that doesn't exist, it will error out for us, and we can check the previous exit status of that process and see that it is a 127. That's a common error code in Unix or Linux systems. And so that is how this health check works. Under the hood, if there's an exit code of 0, it's healthy. And if it's not 0, it is not healthy. And then so what happens after that is that anything that depends on that service for being healthy will also be able to say, oh, this whole system's not healthy. Then you can log stuff out, or you can just turn off everything, or other services will be marked as unhealthy as well. So now let's get back into our compose file. Now there's a couple more attributes that you want for your health check. There's interval, which is pretty self-explanatory. This is the amount of time it'll run every 10 seconds. We want a timeout, and then we want retries. Now this is the amount of times it will retry before it actually says that it is not healthy. If it gets 5 retries of a non-zero exit code, this service is unhealthy. Okay, so now we've looked at one of the services in our setup. It's only 2 services, so we have just one more to go. But this one you'll see is just a little bit different, but we'll explain why as we get into it. Now our second service here is the web service. This is our actual web server. And for this service, instead of an image command, we have a build command. And our build command is set to dot, which is just a path, and that path is this current directory. That's what dot means. But why do we have a build command instead of an image command? Well, our web service is something that we're working on locally. We want to actually develop on our web service. So we don't want to work off of an image that's already been built off of a Docker file. We want something more dynamic than that. So this service gets rebuilt whenever we launch it. And the build command specifies a file path where a Docker file should be. Now in Rails, there's a convention that a Docker file is in the root directory of your project. So for us, we are saying our web service, which is Rails, is going to build from a Docker file in our current directory. And we can see there is a Docker file in our current directory. Now I'm not going to go over the Docker file. Essentially what it does is it builds up a Rails development environment, but that is what we are using to build the image for this service that gets run in Docker Compose. Okay, so now let's go back to our compose.yaml file. And next up we have a command attribute. Now this command attribute is what this service will run after the image is built from our Docker file. So we're going to build our Docker image, which installs Ruby on Rails and installs all the gems and libraries that are needed and gets everything all set up. And then we run a command which essentially just runs our Rails server. We can see at the very end of this line, it says bundle exec Rails S, which stands for server, and then it gives us a base IP to start from, which is essentially localhost. Next up, we have the volumes attribute. Now this is similar to what we used in our DB services volumes attribute, but it's got one little difference. You can see right here, instead of specifying the name of a volume, we specify our current working directory, which is dot. And then on the right-hand side, which is the containers data, it's in /Rails. Now this is specified in our Docker file. If we look really quick, the Docker file to create this Rails environment has a work dir, if I could type directly, a work dir of /Rails. So on the container that is built from this Docker file, the working directory is /Rails. Okay, so what does this do for us? Well, let's explain. So in the database version of using volumes, we name a volume called PG data, and then we mount that volume onto our container at a special file path that is specific for Postgres. So in our web service, what we're doing is we're taking our current working directory as if it was a volume and mounting it into the Rails directory of the container. Now this is amazing because what happens is when we make changes to files in this directory, in this project, they get loaded by this service. This service has has a folder called /rails that is just this current working directory on this local machine mounted at that position. Next up, we define ports. Basically under ports, this is just port forwarding. Now Rails runs at the port of 3000, and so what we want is to forward our local port of 3000 to this container's port of 3000 so that it just kind of seamlessly runs locally on our machine. We don't have to do anything crazy to actually connect to this Rails service. It's kind of just feels like it's local for us. And then we get to a very interesting attribute called depends on. Now this is going to refer back to our health check that we made for our database service. What happens here is we depend on our database service that the condition is service healthy. So if the database service is ever unhealthy, then this service, the web service, will also be marked as unhealthy. That's how we make sure these multiple service environments are all working correctly. It's not like this Rails service is going to run when the database service is down. If the database service is down, the Rails service will also report that it is down as well, which is really great to have in a multi-service environment. And last but not least, we have an environment attribute for our web service, and this just contains a few environment variables that we need in our Rails environment. Nothing really too crazy here. This is just something that Rails needs. Okay, so now we've gone line by line down our Docker Compose YAML file and explained what each attribute does. Now let's actually run Docker Compose and see how we can get these services talking to one another and just see how the system runs. So once you have a Docker Compose file in your current working directory, all you have to run is Docker Compose up. This will spin up every service in that Docker Compose file, and if it doesn't have the image that it needs, it will download it, it will install all the dependencies, and it'll do all the things for us. Let's see what happens here. Now, of course, you can see that this is my first time running it, so we are downloading all these libraries, we're downloading our database service dependencies and our Rails service dependencies, and we're getting everything set up. And we can see here that everything is set up. It looks like our Docker Compose file worked. We have two services. We can see here that we have a DB service and a web service on the left-hand side here. We can see these two different services and they're up and running. Okay, so everything is up and running, but how are these things talking to one another, and are they talking to one another? Can we check that out? Actually, yes, we can. But first, let's explain how these services talk to one another in Docker Compose. So as you saw, we set up before, we have two different services here. We have the database service and we have our web service. And Docker Compose kind of encapsulates all of these services together for us, okay? So this is our Docker Compose environment. So how does our database service actually talk to our web service? Well, what's really interesting is that Docker Compose has its own internal network, and it also has its own DNS. So our DB and our web service, as you can tell from our Docker Compose file, were named DB and web. So these names are recorded in the DNS for this Docker Compose setup. And so what we have here is a DNS that maps our DB service to the correct port and our web service to the correct port. So when our web service wants to talk to the database service in order to, store some data or whatever, it goes through the DNS and it talks directly to the DB through the DNS of Docker Compose. So web doesn't have to know any kind of special IP for this database. It just needs to know the name of the service, which is, of course, DB. So our web service, all it has to do to connect to the database is use this URL, db:5432. Now 5432 is the default port for Postgres. You can define what port you want it to use, but that's the default. And this makes it so much easier for these services to communicate with one another in Docker Compose. Now let's see this in action. So first things first, we have our Docker Compose spun up right here. We have all the logs, but I kind of don't want to run this where it takes up my terminal window here. So let me Control-C out of it. And what you can do is you can pass the D flag to make it run in a detached state, so it won't take up your terminal. So if we run Docker Compose up -D, it will run in detached state. We can see that our web service was up and running. And actually what's interesting here, you can see the order of events. It waits for the database service to report that it's healthy before the web service is started, which is pretty cool. So now since it's in detached state, we can actually control our terminal again. Now, of course, if you want to see the logs for these services, you can just run Docker Compose logs and then the name of your service, and you can see your logs. And then you can also do -F if you want to tail those logs and, whatever. So now let's get into our web service and just check how it communicates to the database service. So you can run something on a Docker container in Docker Compose by typing Docker Compose exec. this will execute a command on a container. Now we can type the web service and then the command we want to execute, which for us is going to be bash. So docker compose exec on the web service bash. So now we're in a bash environment in our web service. You can see that we're actually at our mount point for our volume, which is /rails. Pretty cool. So we can type curl db5432 to see if this communication line is set up. And of course it is. I know this looks like maybe it isn't, but it got an empty reply from the server because Postgres doesn't have just a reply that it'll do to a curl request. So we know that this communication is up. Now we can check if we do just curl something, that's cannot resolve host something. So when we type curl db:5432, we can resolve that through our DNS lookup to the database service. And then the database responds with empty reply. I don't have anything for you, which is awesome. So now we can see that these two services are communicating seamlessly with one another. Okay, so I said we'd actually work on this web environment together and actually work on an application. Let's do this now. This is a Rails application, so let's just make, I don't know, something simple like a blog post and just check that we can save things on the database in our database service and that our web service responds correctly to web requests, namely, the browser. So we remember that we actually launched our Docker Compose in a detached state. So if I want to see the logs for web, I can see that, yep, web is currently up and running. So if I go to my browser, and if we go to localhost 3000, of course, we see the Rails splash screen. That means that this is a new empty application that is correctly running for Ruby on Rails. Perfect. So that means that our web service is up and running the way it should be. So let's create a new feature in this Rails app, right? We want people to be able to create blog posts, okay? So with Rails, we can use something called a generator to generate some views and some database migrations and also controllers in their actions, so that with one command we can put together all of the necessary framework for having a user be able to create posts. Now we want to do this on our web service because our web service is currently connected to our database. So let's go ahead and run this now. We want to run docker compose exec on the web service bin rails generate scaffold, which is the thing that will generate all of the stuff that we need. And we want to generate a scaffold for a posts model. And each post can have a title, which is text, and content, which is also text. Okay, so now we have generated all the things that we need in Ruby on Rails to be able to see posts and create posts and do all that stuff. Now, if we go back to our browser and we go to /posts, then we see here, this is actually a good thing that migrations are pending. So we have to run bin rails db migrate. So what happened here is Rails generated the schema that is needed to actually create a post and to view posts and all that stuff, but we didn't actually run the migration in Postgres. So this is our web service telling us that we need to run a migration, and this migration is going to happen on the DB service. So let's see if this can work. This will tell us if our Rails environment is correctly set up and communicating to our database environment. So to run our DB migrate, we want to run docker compose on our web service bin rails. And again, this is coming from our error here. It says we need to run bin rails db migrate. We run db migrate, and I forgot we actually want to have exec here. So it's docker compose execute on the web service bin rails db migrate. Let's see how this works. Okay, great. So Rails has now migrated our database, meaning it created a schema for posts in our Postgres database. So now the schema is in our Postgres database, and our web service seems to be talking to our database service seamlessly through docker compose. So now let's see if we can create a post with our newly scaffolded post framework now, okay? So we're at our browser and we can go to our posts endpoint, and we see here that we can create a new post. This is part of, again, this is a very Rails specific thing. Rails will generate all the views, all the controller actions, and the database migrations and all that stuff for us so that we can just sort of play around with it. Now let's see if we can create a new post. And of course we have a new post, and this is picked up by the Rails model. It knows that we have a title and content. So this title is going to be some post, and the content is going to be Rails is awesome. with Docker Compose. So what's going to happen when I click on create post here? Well, our web service is going to have this action in a controller. The form will submit to that action to create a new instance of a post in our database service in PostgreSQL. So when we click create post, it will traverse all these things and create a post in our database service. And there we go. The post was successfully created. So now if we go back to post, this is our index, and now we can see that our Rails application is correctly creating and fetching posts from the database service in Docker Compose. So this was a simple but effective Docker Compose file that was able to spin up multiple services and have them talk to one another seamlessly. Now, if you want, I have a repository linked down in the description below, so check that out and make sure to subscribe for more Docker, Vim, Linux, and other tips and tricks. And hey, thanks, nerds.